This is Geometry, Chapter 6, Section 1, Polygon Angle Sum Theorems. Okie dokie. So, we all know that when we have a triangle, and if we were to add all the angles inside of a triangle X, Y, Z, we know that if we add them all up, measure of angle X plus measure of angle Y plus measure of angle Z, if we were to add all of those guys up, it would equal up to 180 degrees. All right. What do I notice about an angle? An angle has three sides. Sides 1, sides 2, sides 3. In the world of geometry, we can use a symbol to represent the word side. And we can say that N, the letter N, is the same thing as saying a side. So we would say that for a triangle, N would equal 3 for the number of sides. A triangle has 3 sides, and it sums up to 180. So let's put a chart to this. Let's say we have a chart. And let's say for our little charty chart, we have number of sides, call that N, number of triangles, and degrees, because it equals 180 degrees. So for a triangle, it has 3 sides. There's one triangle, and it's 180 degrees. What if I had a square, or 4 sides, a quadrilateral, or a rectangle? Well, you know, I can put a line through here, and I can say that I have 1 and I have 2 triangles. And how many sides does a quadrilateral have? A quadrilateral has 4 sides, 2 triangles. And if I was to add it up, let's say this is a rectangle, this is 90, this is 90, this is 90, this is 90, we would have 360 degrees. What if we had a pentagon? And maybe you guys might start to see a pattern. See, 1, 2. This won't be to scale. I'll try the best that I can. 1, 2, 3, 4, and 5. So I have 1 triangle, 2 triangles, 3 triangles. 1, 2, 3. So now I have 5 sides. I have 3 triangles. And I have another triangle is another 180. So that's what, 520? Let's see. 540 degrees. So hopefully we're now starting to see a pattern. Here, let's say instead of the next number 6, it would be uh, n triangles or n sides. And then this would be n minus 2, right? 3 minus 2 is 1, 4 minus 2 is 2, 5 minus 2 is 3. And find the number of degrees is actually the polygon angle sum theorem, which is going to be n minus 2 times 180 degrees. So we would get the number of triangles times 180 degrees gives us the total degrees in the triangle. So one triangle times 180, two triangles times 180, three triangles times 180. That gives me the total number of triangles. So 360 for 4 sides would be 2 triangles, I'll just say 2, times 180. For a quadrilateral. A pentagon, which is 5 sides, would be 5 minus 2, which is 3 triangles inside a pentagon, times 180. That gives me the number of angles inside of that particular polygon. If we had a hexagon, it would be 6 minus 2 would be 4 times 180, and that would give me the number of degrees inside of a hexagon. Again, which leads us to our first theorem of the semester, number 2. And that is the polygon angle sum theorem. Says that the sum of the measure of the interior angles of an n-gon is n minus 2 times 180. Polygon angle sum theorem, n minus 2. So the number of sides minus 2 gives you the number of triangles. You multiply that times 180. How many angles are inside one triangle? And that will give you the total number of angles inside of a polygon. And interior angles inside, interior angles of a polygon. So here it says for 1a, what is the sum of the interior angle measures of a 17-gon? So if we have a 17-gon, this is going to be 17, right? Actually, I said it. The number of sides is equal to 17. So 17 minus 2 times 180 degrees is 15 times 180. And that gives me a number of 2700 degrees. Theorem number 1. Alright, so we have different types of polygons classified by the number of sides and by the angles. The first one here, they give me a polygon. It has 1, 2, 3, 4, 6 sides, so this is a hexagon. 1, 2, 3, 4, 5, 6. And notice that all the markings are on every side, so that means that all the sides are congruent. So we would call this an equilateral polygon. Equilateral polygon. And an equilateral polygon is a polygon with all congruent sides. With all congruent sides. And we have an equiangular polygon, Notice that all the markings denote that all the angles are the same. So equiangular polygon is a polygon with all angles congruent. With all congruent angles. Then we have when they're both equiangular and equilateral, we call those a regular polygon. So a regular polygon is a polygon that are that is both equilateral and equiangular. Okay. Lateral for sides, equi for equal. It's a polygon with equal sides, all equal sides. Equiangular, equi for equal, angular for angles. Polygon with all congruent angles, and then a regular polygon combines the two, and it's when they're both equiangular and equilateral. All right, so corollary to polygon angle sum theorem. What the corollary says to the polygon angle sum theorem deals with equiangular or regular regular angons. So the corollary to polygon angle sum theorem says this. We know that all the angles of an interior angle is n minus 2 times 180. What the corollary says is what happens if we have a regular polygon or a regular n-gon. And what the corollary says is that if we have a regular n-gon, then we can just divide it by the number of sides to get the measure of one angle. So, measure of each angle of a regular n-gon is n minus 2 times 180 degrees divided by n, the number of sides. N minus 2 times 180 degrees divided by the number of sides. So if I know, and this is only for a regular n-gon, this doesn't apply to any other but a regular n-gon, where all the angles are the same. So if I add them all up, right, this is a hexagon. I know a hexagon has 6 sides. So if I was to plug it in and find the total number of interior angles, it'd be 6 minus 2 times 180, which is 4 times 180, which is 720. That gives me the sum of all the interior angles. If I have a regular polygon, I'm going to divide that 720 divided by the total number of sides. It's 6 sides. And that's going to give me one angle of a regular hexagon. So one angle inside of that hexagon is worth 120 degrees. So what does that mean? Well, if I was to it's not to scale, but that means that every angle, when it's a regular hexagon, is 120, 120, 120, 120. It only applies to regular polygons. Okay. So here, what is the measure of each interior angle of a regular nonagon? So a nonagon has 9 sides. I know that the sum of the interior angle is n minus 2 times 180. And if I know it's a regular nonagon, I divide it by n to find the total number of sides. So this would be 9 minus 2 times 180 degrees over 9. And that would give me 7 times 180 over 9. Which would give me 1,260 divided by 9, and that gives me 140 degrees. So one angle inside of a regular nonagon is 140 degrees. Alright, using the polygon sum angle theorem, we have some polygon E, F, G, and H, so it's a quadrilateral. E, F, G, and H. And we're given that this is 85, this is 120, this is who knows what, and this is 53. They want to know what the measure of angle G is. Who knows? What I do know is that the total number of angles inside a quadrilateral is 4 minus 2 times 180, which means that's 2 times 180, so it's 360 degrees. So there's 360 degrees inside of a quadrilateral. Since I know that, I can add all these guys up together and find the missing angle that way. So I can say that it's 120 plus 85 plus 53 plus the measure of angle G, and that all has to add up to 180. I add all of those angles up together, 120 plus 85 plus 53. I have I'm sorry, 360. I get 258 plus the measure angle G equals 360. I subtract 258 from both sides, and I get that the measure of angle G equals 108 degrees. Okay, so again, I knew that I was dealing with a quadrilateral. I know a quadrilateral has 4 sides, n equals 4. So I plug in the 4 over here. 4 minus 2 equals 2, and 2 times 180 equals 360. So all of these angles inside of a quadrilateral equals 360. I add up all the angles that I do have, subtract it from 360, and I get the angle of measure G, or measure of angle G. All right. So we have an exterior angle. They give us 100, 50, 30. Remember that the exterior angle extends out, and it always forms a linear pair with the interior angle. So 30 and 150 equals 180. 180 equals 180. 50 and 130 equals 180. And if I was to add all the exterior angles, the angles that form linear pairs with the interior angle, we get a pattern. And here's a quadrilateral. They have all these exterior angles. If I was to add all the exterior angles of any polygon, they would add up to 360 degrees. So that leads us to the Polygon exterior angle sum theorem, which says that the sum of the measures of exterior angles of a polygon at each vertex is 360 degrees. The sum of the measures of a polygon at each one at each vertex. I'm just going to say it's 360 degrees. Okay. If I add up all the exterior angles, they all sum up to 360 degrees. Okay. What's the measure of an exterior angle of a regular nanogon? So if I want to find one regular nanogon, I know that the nanogon has 9 sides. I know that the sum of all the exterior angles is 360 degrees. So what I would do, since it's a regular nanogon, that means that all the exterior angles would be the same because all the interior angles would be the same. So I would have 360 degrees and divide it by the total number of sides of a nanogon, which is 9. And I would say that each exterior angle would be 40 degrees. Let's use a square for an example. Or we can even use a triangle. So let's say we have a triangle, and let's say it's a regular triangle. We know that the interior angles of a regular triangle are all the same. That would be 180 divided by 3. And that would give me 60 degrees. So all of these guys is 60. Make this bigger and better. So this is 60, 60, 60. If I was to extend out and get the exterior angles, right, what would this guy be? What would this guy be? What would this guy be? Since all of these guys are the same, right, we can subtract from 180 and this would be 120, 120, 120. But let's say we didn't know that. We call it n. Yeah. We have one side, two side, three side, right? The same thing applies. So 360 divided by 3 gives me 120. 120, 120, 120. And the reason why this works is because since all of these guys are the same, then all of these angles must be the same. So I would just divide 360 by the number of sides, and that would give me each exterior angle. Alright, so that's this section. Welcome back. Happy New Year. I hope you have a great rest of your day.